In this chapter, students will build fractions from unit fractions by applying and extending previous understandings of operations with whole numbers. Students will understand decimal notation for fractions, then compare and add and subtract decimals to the hundredths. This chapter will build upon fraction foundations from 3rd grade. The first prerequisite skill is understanding that any fraction is composed of iterations of a unit fraction. For example, 5/6 is 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. The next prerequisite concept students need is an understanding of what a multiple is. A multiple of a number is the product of that number and any other whole number. The next prerequisite concept is expanded form. Expanded form is a way to write whole numbers that shows the place value of each digit. Students have learned about how to write whole numbers in expanded form as a set of addends and as pairs of factors. Let's move on to the concepts and skills taught in this chapter. In this chapter, students will extend their knowledge of whole number multiplication and whole number multiples to multiplication of a fraction by a whole number. They will start by repeatedly adding a fraction and relating this to multiplication. For example, 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4 is the same as 6 groups of 3/4 or 18/4 or 6 times 3/4. Students will use area models, number lines, Cuisenaire rods, and pattern blocks to model multiplication of fractions. In a number line, this would be shown by jumping 3/4 6 times. Each jump is a multiple of 3/4 and ending at 18/4. Here is another example of 6 groups of 3/4 modeled using an area model. Students will then write an equivalent multiplication equation. For example, students will work to see that 6 times 3/4 is 18/4, meaning 18 pieces, each the size of 1/4. Using models, they see that 6 times 3/4 is the same thing as 18 times 1/4. Students will then be asked to change the fractional form of a number in which the numerator is larger than the denominator into a mixed number. Let's continue using 18/4. Let's model using cubes. We can draw stacks of 4 cubes until we have drawn a total of 18 cubes. We can see that 18/4 is equivalent to 4 whole stacks of 4 cubes and 2 of the 4 needed to complete another stack of 4 cubes for a total of 4 2/4 or 4 1/2. The last concept students will work on is decimal notation. Students are introduced to 10 and 100 as denominators and how they relate to both fractions and place value. Students will learn that a fraction with a 10 in the denominator has the same value as a digit in the tenths place value, and a fraction with 100 in the denominator has the same value as the hundredths place. They learn that fractions and decimals are the same numbers written differently rather than different types of numbers. For example, 4/10 can be written in fraction form as 4 tenth-size pieces or as a decimal with a 4 in the tenths place. They also learn to write a fraction with a denominator of 10 as an equivalent fraction with a denominator of 100. For example, let's look at 23/100 in the place value chart. 23/100 is the same as 2/10 plus 3/100. Students know that 2/10 can be regrouped to make 20 hundredth-sized pieces, so the fraction can be rewritten as 20/100 plus 3/100. Next, students will use a metric ruler to find numbers on a number line. Let's try placing a decimal on the number line, 73/100. To find the decimal, let's narrow down its location by determining what 2/10 it is between. It is larger than 7/10 and smaller than 8/10. Then create a magnified number line for the section between 7/10 and 8/10, or 70/100 and 80/100. Now mark the 73/100 spot. Then, students move on to comparing decimals to the hundredths using a number line and a place value chart. Let's compare 2 decimals using a number line, 53/100 and 35/100. Start by drawing a number line from 3/10 to 6/10 and divide it into hundredths. Place the 53/100 3 marks past the 5/10 and label it. Next, place the 35 hundredths 5 marks past the 3/10 and label it. It is clear that 53 hundredths is to the right of 35 hundredths on the number line and is therefore larger or greater. Students will learn to add and subtract decimals to the hundredths using hundredths grids, place value charts, and place value blocks. Let's solve 3 2/10 plus 1 56 hundredths using a place value chart and place value blocks. Let's start by modeling the first add-in of 3 2/10. Place 3 flats in the ones column and 2/10 rods in the tenths column. Next, let's model the second add-in. Place 1 flat in the ones column, 5/10 rods in the tenths column, and 6 hundredths cubes in the hundredths column. Now add. There are 6 hundredths, 7/10, and 4 wholes. The sum is 4 76 hundredths. Next, students will write decimals in expanded form. Expanded form is a way to write a number by decomposing it into individual place value parts. Expanded notation for any number may be written as a set of add-ins, for example, 30 plus 2 plus 5/10, or it can be written as pairs of factors, 3 times 10 plus 2 times 1 plus 5 times 1/10. Students will use place value discs to represent the numbers in both fraction and decimal form. Here you see 3 tens discs, 2 ones discs, and 5 tenths discs. It can also be modeled using fraction discs as 3 tens discs, 2 ones discs, and 5 1/10 discs. Both models show the same number of 32 5/10. In this chapter, students build fractions from unit fractions by applying and extending previous understandings of operations with whole numbers. Students learn decimal notation for fractions, then compare and add and subtract decimals to the hundredths. Taking the time to give students the visual representation of fractional operations will help them understand why algorithms work.